right. Let's get the show on the road. Okay, guys, so welcome. We are grade 12s is hopefully we have grade 12s here in the house, in the building, because we're going to have a live lesson for grade 12s, and we are basically still busy with what sequence and series. That's what we've been busy with, guys. So we are going to take it one little bit of a step at a time. Welcome to everyone. I hope you guys can double tap on the screen. Let's get the live, at least let's get our milestones achieved. 1K likes, 2K likes, and so it goes. All right, so let's look at, we're gonna jump in straight today. All right, hopefully we can utilize all the time that we have available, and we can actually make sure that we are covering a lot. All right, which grade? It's grade 12. We are doing the concluding session of sequence and series today. So if we look at this question here, it says calculate. Right, this is basically picking up where I left off yesterday. It says calculate 2 plus 6 plus 18 plus 54 plus, and then there's like this myriad of dots, and then we have plus 4,374. So what does this say to you guys? It says to you, first and foremost, what do we have here? What do we call this? Let's see if people know their stuff. What do we refer to this as? I'm gonna give you guys a chance to let me know in the comment section. What do we refer this as? What is this? 2 plus 6 plus 18 plus 54 plus ... plus 4,374, because we are supposed to calculate this. That's all that this question is saying. We haven't been told anything else. So what is this, my beloved grade 12s? What do we refer to this as? What is it? Okay, Noping, it is indeed a series. Why do we refer to it as a series, Noping? Okay, because you didn't say it's a sequence, you said it's a series. All right, and it's important that you have made that important identification. But the question then is, since you said it's a series, why do you say it's a series? Why didn't you say it's a sequence? What sticks out as a way of identification of a series, of it being a series? Okay, Pills Door, I see what you said there. Okay, thank you, Evile. There is a plus. All right, yesterday I think it was Miss Zim, when I was trying to explain the difference between a sequence and a series, Miss Zim then indicated yesterday that a series will have terms separated by either a plus or a minus sign. All right, remember, sometimes if it's not a plus sign that's there, sometimes depending on the value of the term, sometimes because it's a negative, it means that positive, and that negative basically makes it a negative sign. So you'll have a plus minus, plus minus, plus minus, or you'll have a positive sign that is separating the terms. Okay, so thank you so much for that identification. Second question, what type of series is this? What type of series is this? Thank you, Nopingi, for your comment, and thank you, Evile, as well, for your invaluable comment. You guys are giving very valuable comments. So now the next question that I'm asking now is, what type of series is it? Phoebe Grace says geometric with a question mark. Evila says geometric series with no question mark. So Phoebe Grace, what I want you to do, No, Pinky says geometric. Phoebe Grace, I want you to change that question mark to an exclamation mark to indicate that you are not saying it whilst still doubting or questioning that it might be something else, but you are sure. Because we must be sure. We can't be iffy, wishy-washy. Now, at this point, because you've learned the concept, you should be able to say it's geometric. Thank you so much, Phoebe. So it is geometric. Why do we say it's geometric? Why do we say it's geometric? Because Ivile says it's because we multiply by 3. What is that 3? What do we refer to that 3 as? Okay, Nopingi says our ratio. Ivile says the ratio. So yes, we have a constant, or what we refer to as a common ratio. All right. Okay, thank you so much for that. Yeah, so that's what we do. So what we want then is to calculate the what then, guys? The sum of what? Of this geometric series. Why do we know for sure that it is the sum of the geometric series? Because we are given all the terms in the series, including the last term in the series. So we know from where the series starts and we know where it ends. So therefore it means we have to calculate the sum of this geometric series. If we already know it's a geometric series and we know what the ratio is, what formula do we use when we are calculating the geometric series sum? All right. And furthermore, how will we know how many terms this series actually contains? Because remember, more than anything else, we need to know how many terms the series contains. This is for 7 marks, by the way. And remember, we have a formula, but we need A, we need R, and we need N in order to calculate the sum of this series. I think as far as A, okay, you use the last term to find how many terms, but first find the formula. Okay, thank you so much, Sentlantla Mazibuko. Sentlantla Mazibuko has got some understanding there. Okay, all right, thank you so much, Sentlantla. We will use the last value, Tn. Thank you so much. You guys are, yeah, you definitely know what you guys are doing. So first and foremost, all right, obviously we A, R, okay, and then of course N. What is A? A is the first term. What is the value of the first term? Okay, I'm really taking things slow today, guys. Yes, 7 marks. Very true, because we need N first. Okay, A is 2, because A is the first term. What is the value of R? Okay, you guys already told me what R is. Okay, 3. T2 divided by T1, which is 6 divided by 2. That gives us 3. N, we are going to have to first figure out what the value of N is. Okay, so remember, guys, that as we have been told by those in the comment section, to find N, we are going to use Tn is equal to AR to the power n minus 1. We are going to use the Tn formula. And what we're going to do is we're going to first find what the nth term is, because A is 2, our R value is 3, all raised to the power n minus 1. So that is Tn. And after that, we take Tn, we equate it to 4,374. Why do we equate it to 4,374? Why? It's because we know that 4,374 is the last term in our what? In our series. So if we can find what is the position of that last term, remember Tn is 2 times 3 to the power n minus 1 equal to 4,374. If we can find the value of n, of course, that will mean we will know that if, for instance, we find out this is the 50th term, then it means in total, how many terms do we have? It would mean we have 50 terms. If we find out that n is 17, because remember that n will indicate the position of the last term. And if we find out, for instance, that n is equal to 12, that means that the number of terms we have here is 12. Okay, so all I'm saying is that whenever we want to find the position of the last term, we equate Tn. After finding out first what Tn is, we equate that to the last term. Then we solve for n. And you can see, guys, that our n exponent is going to require our knowledge of solving for exponential equations, which is important because we learned that very well in grade 11. So now let's proceed. We have now 2 times 3 to the power n minus 1, which is equal to 4,374. And what do we want to do? We want to solve for n. So if we look at the relationship between the bases, I'm sure you guys can solve this quite easily, but for the benefit of those that are here and may not particularly know how to do this, we have 2, which is the coefficient of 3 to the power n minus 1. So we are going to divide both sides by what? By 2. So let us do that. And what are we left with after we divide by 2? So I'm going to turn over my page, guys. 2 times 3 to the power n minus 1 is equal to 4,374. Was it? Is that correct? Okay, just want to verify that. Yes. So 2 is the coefficient. So we are going to divide both sides by the 2 to get rid of it. So when we do that, what happens, guys? When we divide both sides by 2, we are left with 3 to the power n minus 1. What's 4,374 divided by 2? My beautiful, efficient calculator people, or those who have the mental maths capacity to basically give us answers just like that. Bontle, you beautiful thing. No, Pinky, thank you so much. So we have 2,187. Now, guys, I just want to say that, all right, we can now take this 2,187, and as per what we've learned in previous grades, we can change this composite base to a prime base using our calculator. Or if we don't want to go that route, we also have been exposed to solving an equation in an alternative way. But let us explore if whether 2,187 equal to shift and fact, what does it actually give us? Wow, we get 3 to the power 7. Let me just review what I did there. 2,187. We press the equal sign. We then press shift. Then we press fact. And then we get the prime base exponential form of 2187, which is 3 to the power 7. So then we can go there now and write 3 to the power n minus 1 is equal to 3 to the power 7. Then when bases are the same on either side of the equal sign, what is the rule for exponential equations? Okay, so remember very well that the rule says if a to the power x is equal to a to the power y, then x is equal to y. So if bases are the same on either side of the equal sign, we drop the base, we equate the exponent. So x is equal to y as long as the bases are the same. Then we say n minus 1 is equal to 7. Why? Because the bases are the same. Alright, then we solve for n. This is a linear equation. We take our negative 1, we transpose it. It becomes what on the other side? Definitely positive 1. Thank you so much, Wontle. Such a joy. Then n is equal to 8. So we now know that because the position of 4374 is 8, in other words, this 4374 is the 8th term. As the last term, it's the 8th term. It means how many terms do I have in total since this is the last term? It means that the number of terms that are there or are supposed to be here, including the ones that have not been written down, in total gives me the number of terms that are 8 terms. I have 8 terms in total, guys. So that means because my n is 8, I now know that the number of terms, I have 8 terms in total. Now, I think now we can proceed and find the value of the sum of the number of terms, the sum of 8 terms. So let's recap again. Our a value was 2, right? Our r value is 3. Our n value is 8. The formula that we use to calculate the sum when the geometric series has a value of r that is greater than what? Is which formula? When r is greater than what do we use that formula? All right, that's very important because we need not forget that. So because this is a geometric series, the formula we use is sum of the first n terms is equal to what? Our r value, guys, is positive 3. R is greater than 1. No, r is greater than 1. So when r is greater than 1, we established that we use this formula. A, thank you, Sakhamete, for the heart me, really appreciate it. A into r to the power n minus 1 over r minus 1. That's what we established we use when r is greater than 1. If r was less than 1, there is another formula for the sum of n terms in a geometric series whereby 1 is first minus r to the power n over 1 minus r. That one we use when r is what? Is less than 1. But when r is greater than 1, we use this particular formula. All we do now is simply substitute. The sum of the first 8 terms is equal to a is 2, r is 3 to the power what? 8 minus 1 over what? Over 3 minus 1. You then grab your calculator, guys. As straightforward and as simple as that is, you grab your calculator, you punch in the fraction 2 at the top. Okay, brackets, you take the 3 to the power 8. All right, then make sure that you drop the cursor, minus 1, you close the bracket, and then at the bottom it's 3 minus 1. Then you say equal. Then your calculator will give you the final answer, which is the sum of the first 8 terms in that geometric series, which is, guys, I'm sure you also saw the sum of the first 8 terms is 6,560, and that's that. So that is as straightforward as we actually go about finding the sum of the first 8 terms in what was not initially clear as to whether we were supposed to find the sum of the first 8 terms. Why? If we go back, guys, and relook at the question, what was the question? The question simply said, calculate 2 plus 6 plus 18 plus 54 plus ... plus the last term was 4,374. For how many marks? For 7 marks. So what we saw first and foremost is, okay, we asked ourselves, what is this? Because they just want us to calculate it. Guys, the word calculate does not mean use a calculator. The word calculate means you need to show step by step how to find the sum of this series. Okay, the word calculate means show step by step. The word calculate and determine in mathematics means show step by step how to go about finding the sum of this of this series. Okay, right. So I hope you understand that. So we established in the beginning that this is a series. Then secondly, I asked what type of series, and people then were able to find the value of R and then confirm that it is a geometric series. It's not just any ordinary type of series, it's a geometric series. Why do we say it's geometric? Because the value of R, guys, okay, consistently is 3. We have a constant ratio. When you take T2 and you divide it by T1, you get 3. You take T3, you divide it by T2, you get 3. You take T4, you divide it by T3, you get 3. So there's a constant ratio. There's no constant difference. Because when you say T2 minus T1, we get 4. 18 minus 6, we don't get the same value. So this is not a arithmetic series. It is a geometric series. Why? Because the value of R is 3. Okay. So we established that A is 2. A is the first term. R, the constant ratio, is 3. Then in our heads we were like, okay, we need, when we are calculating the sum of a series, we need to know how many terms do we have in total. When we look at this series, the one way in which we can be able to find or understand the number of terms we have is if we take the last term in the series and find the position of the last term. Remember, n in Tn means the position of the term. So if we can figure out what number term this is, then by so doing, we'll be able to then know how many terms there are. For instance, if I find out that this is the 50th term, then that will mean that in total there are 50 terms in this series. If I find out that n is equal to 12, in other words, the number of terms, the position of this term is 12, then it means that in total the number of terms, there are 12 terms in the series. So what I did is I took Tn for a geometric series, found what the formula of Tn is by substituting A, which is 2, and substituting R, which is 3. 2 times 3 to the power n minus 1 is the nth term. After so doing, I took the nth term and I equated, or I made it equal to 4,374. Then after doing that, the nth term, which is 2 times 3 to the power n minus 1, I made that equal to 4,374 as has been equated. Then I solved for n. using my understanding of exponential equations. After so doing, divided both sides by the coefficient, which is 2. When I did that, that led me to 3 to the power n minus 1, which is equal to 2187. Then I converted my composite base to a prime base by using my calculator. Took 2187 equal to shift fact, gives me 3 to the power 7. And then thereafter, thank you so much Mayo for the rose. Then thereafter I dropped the base 3. Why? Because there's a rule that applies for exponential equations. What does the rule say? If the bases on either side of the equal sign of an equation are the same, then all you do is you simply drop the base a and you equate the exponents. X is equal to y. So I did the same thing here. It's base 3, base 3. I dropped base 3 on either side, and I took n minus 1 and made it equal to 7. Then I solved for n. Therefore, n is equal to, took the negative 1 over to the other side, n is equal to 8. Now, because I know what n is, the position of that 4,374 is 8. It's the 8th term. So what does that mean, since my 8th term is actually 4,374? How many terms in total do I have in my series, since the last term is term 8? How many terms do I have in my series, since my last term is term 8? How many terms do I have in the series, since my last term is term 8? It means that I have a total number of terms, that I have 8 terms. So after that, I took now the updated information. A is equal to 2, I knew that. R is equal to 3, I knew that too. N is equal to 8. This is what I've just found, because the sum of the number of terms is 8. I use this formula specifically because it is used whenever my R value is greater than 1. Substitute A, which is 2, R, which is 3, N, which is 8, and then use my calculator very beautifully, as you saw here. And then I got my answer, 6,560, which is the sum of the first 8 terms for that series. Simple, straightforward, to the point, guys. Okay. All right. I hope we are okay and we are ready to proceed on to the next question. Okay. Trying very hard to sort of like take it a bit slower than I usually take it, right? And I hope that is also helping facilitate sort of like a bit of understanding for even those that may feel that many times I'm very fast. Okay, all right. Okay. In focus. Been doing a lot of problems that are sort of like just, so we're going to look at a word problem here, quite wordy, okay, and it goes as follows: a small amphitheater. I don't know if any of you have actually been to or have actually gone to a amphitheater, but let me just try and do this quickly. I hope amphitheater. Those who know anything about those that like acting, guys, yeah, pulling up some pictures here. So that you can sort of like visually picture what an amphitheater is. But there's a stage there, and then there's where people sit. Okay, this is like an amphitheater. it's where people sit, and it's like row by row people sit and they are able to watch maybe some show that is happening. I think this is kind of like a much more massive amphitheater. You can see there, you know, the seats are there, and then this is the stage people are able to watch. So, but here they're talking about a small amphitheater. I'm sure you can see, guys, that there are rows. Some amphitheaters have seats, but this one doesn't have seats, as you can see. Okay, yeah, just depends on the type of amphitheater, but this is like, that's an example of what an amphitheater is. I just want to see this one here. Yeah, you see, that's an amphitheater. Okay, yeah, I hope you guys get the point. All right, so this thing is saying a small amphitheater has 10 seats in the first row. 10 seats in the first row. So this is basically the 10 seats. This is the first row. Seat 1, seat 2, seat 3, seat 4, seat 5, and so it goes up until the 10th. Okay, so a small amphitheater has 10 seats in the first row. Then look, it has 12 seats in the second row. So this is the first row. Then the second row has 12 seats. Okay, and 14 seats in the third row. So third row will have 14 seats. So this is kind of like a visual that they have on this amphitheater. Okay, now let's read what it says here. As shown basically above, that's basically our amphitheater. Now it's saying the pattern is continued. Okay, this pattern of arrangement of seats is continued. Okay, the question that is being asked, the first one, it's saying write down the number of the last seat in the fourth row. What is it saying? Write down the number of the last seat in the fourth row. Okay, now guys, that would be the first seat in the first row. That seat number 10 would be the last seat in the first row. First seat in the second row, last seat in the second row. First seat in the third row, last seat in the third row. So they are saying here, write down the number of the last seat in the fourth row. So that means that there will be an additional row here, which will basically be the fourth row, and they want us to write down the number of the last seat. So it would be the seat located right in line with these seats. Okay, now this is 10, this is 22, this is 36. All right, okay, and rightfully so, Sekhamed, I see what you are doing there. All right, so yes, Sekhamed, because you can see, and I love what Sekhamed is saying in the comment section. They are saying a small amphitheater has 10 seats, right? In the first row, there's 10 in the first row, 12 in the second row, then they are saying 14 in the third row. So what did we do here? Since they are saying the second row has 12 seats, you add 10, you get 20. You add 12 to the 10, you get 22. 14 seats in the third row, we add 14 to the 22, we get 36. Then of course this pattern, 10, 12, 14, of course in the next row it will be 16. Okay, so I hope you guys can see this pattern, all right, that is basically emerging of the seats in the last row. Okay, but it is formed by the fact that in each row, as it says a small amphitheater has 10 seats. The first 10 seats in the first row, but then 12 seats in the second row. So if you add 12 seats to the 10, that means the very last seat here will be the 22nd seat. All right, so I repeat one more time. There's 10 seats in the first row. Then they are saying 12 seats. So you are from the last seat, which is seat number 10. What do we do when we are forming this last row? I mean the second row. We add 12 more seats. If we're going to add 12 more seats, it means 10 plus the 12 seats will give you 22 seats. All right, that's why we have 22 there. Okay, because this will be your 22nd seat. Then it says further, and 14 seats in the third row. So in the third row, we are going to, from the 22nd seat, add 14 seats, and then that gives us 36 seats in this row. I mean, we're going to add 14 seats to 22, and then we are basically going to get the 36th seat as the last seat in this row. Okay, so if you continue with this constant difference pattern here, 10, 12, 14, it means to get the next row, how many seats are we going to be adding? We are going to be adding 16 seats. Here, remember, we added 14. Here we added 12. 12, 14, 16. So I'm sure you can see that from this last row, there is an evident arithmetic pattern or an arithmetic sequence. This forms, the addition is forming our arithmetic. All right, I hope you can see that. Okay, so write down the number of the last seat in the fourth row. If we're going to add 16, then it means the last seat will be what, guys? It will be the 52nd seat. Okay, because we are going to say 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, and lastly, the last seat in this fourth row will be seat number 52. Okay, so write down the number of the last seat. Here they're just saying write down the number of the last seat in the fourth row. It is definitely going to be 52. It's going to be seat number 52. Okay, now before I proceed, is anyone having a particular question or lost about something? So once again, I'm saying a small amphitheater has 10 seats. These are the 10 seats, guys, from 1 all the way to 10. Then they are saying in the first row you have those 10 seats, 12 seats in the second row. So that means if we are going to have 12 seats in the second row, we are continuing from seat number 10, 11, all the way to what? To 22. Because if you add 12 more seats to the 10 that you had, you are going to have your 22nd seat as being the last seat in the second row. Then if you continue to add 14 seats so that you can form the third row, that means the last seat in the third row is going to be seat number 36. Why? Because 22 plus 14 gives you 36. Then remember, this is a linear sequence, 12, 14, 16. All right, so that means you are going to add 16 seats to form the fourth row. If you add the 16 seats to form the fourth row, it means your last seat in this row will be seat number 52. So that's how we get 52 as being the what? Write down the number of the last seat in the fourth row. It is seat number 52. Okay, all right, so I'm gonna just for a moment stop here and see if we are okay. Okay, guys, this is 1 mark. They are saying write down. All right, so you don't want, I mean, there's no, you don't want this. This is basically a logical question, all right? And because it's just one single mark, there would be no need to be using a particular formula, because you see the question is specifically saying write down. They are not saying calculate or anything of that sort. They are saying write down the number of the last seat in the fourth row. So there has to be some sort of like level of common sense and logical application. That's all. All right. So yeah, just logic here. That it's just logic. Yeah, because this is the same, because if you guys think about it, this sequence 10, 22, 36, 52 is actually a sequence that, if you actually look at it closely, is forming what we call a quadratic sequence. 10, 22, 36, 52. Because what is happening here, our first difference is a arithmetic sequence. Our first difference is arithmetic, which would mean that there's a second constant difference for this particular what? This particular last. These terms, 10, 22, 36, 52. All right, I hope you understand that. So logically, if you want to find the next, how many seats are in the next row, you are going to add the constant difference and then you are going to add that first difference and then find the number of seats. So this is what I'm saying. At the end of the day, it goes back to just logical common sense as far as it applies to our constant difference. Okay. Mark Knights Beta, yeah, I think you are sort of kind of interfering, to be honest. Interference. How can you find the value of x when it's cancelling out? That's the question that I have for you, but I feel like I don't have much time for such. Okay, next question. Write down the number of the last seat in the nth row. The what? The number of the last seat in the nth row. So what are they wanting, in other words? They want the nth term in this row. Write down the number of the last seat in the nth row. Okay. So there's a row called the nth row, and they want what? The number of that last seat in the nth row. Okay. So we are going to then take 10, 22, 36, and 52 and find Tn of this sequence. So as I said to you here, guys, we are dealing with what type of sequence here? As I said, we are dealing with a quadratic sequence. How do I know that, guys? The reason why I know that is because I could see that the first difference here, 12, 14, 16, in and of itself is a giveaway to me. 12, 14, 16. That means I have a second constant difference. 14 minus 12 is 2. 16 minus 14 is 2. All right. So here I want to find the nth term of this sequence. That's what they are asking for here. Write down the number of the last seat in the what? In the nth row. Okay. Like for instance, we've been writing the number of the last seat in the second row, number of the last seat in the third row, number of the last seat in the fourth row. Now they are asking us to write down the number of the what? Of the last seat still, but in the nth row. So that's why I'm saying that would be Tn, the nth term. Okay. So let's go and find out what that Tn is. So you guys should then know how to find the nth term for a quadratic sequence. That shouldn't be too much to ask from all of you. Thank you, Sekhamitse, for the "you're awesome." It's really appreciate it. Okay, it shouldn't be too bad there. You can find most Tn. Okay, you guys tell me, how do I proceed? What do I do next? Come on, in you I trust, my beloved grade 12s. How do I find Tn of this US? We know most. This helps a lot. Okay. Ritabile, straight to the answer, my dear. So I'm sure you worked it out there very nicely. So please, let's not forget the expressions, guys. We know most that here 2a would be equated to the, thank you so much, 2a would be equated to 2. So let's first find a. Our a, just to confirm Ritabile's answer, a is equal to 1. Very much true. You are 100% correct, Ritabile. The next expression we use, which is supposed to displace the first term in the first difference row, is 3a plus b. Remember, the a we already have is 1. In the place of a, we substitute 1. Plus b is equal to 12. And then all we do is we solve for b. B is equal to 9. Okay, I think Ritabile definitely got the answer right there. And then last but not least, our last expression that we use is a plus b plus c, which is supposed to be equated with the first term in the original sequence. So that's a plus b plus the c, which is equal to 10. Okay, a 1, b 9, c we want to find. So we substitute the a, which is the 1 there. We substitute the b, which is the 9. We want c, so we solve for c. Okay, so a plus b plus c is equal to 1. Sorry, did I say a plus b plus c? A plus b plus c is equal to 10. Sorry. Then we solve for that. Guys, c is equal to 10 minus 10, because 1 plus 9 is 10. C is equal to 0. So the nth term, so in other words, the number of the last seat in the nth row, the number of the last seat is actually equal to n squared plus 9n. Remember that c is going to be 0, and really and truly that constant 0, no need to write it right there. So there it is, guys. That's the number of the last seat in the nth row. It's actually going to be n squared plus 9n. Okay, n squared plus 9n. And 1, it can't be a is equal to 0. A is equal to 1, because remember 2a is equal to 2. You divide both sides by the coefficient. The coefficient of 2a is 2. So you divide by 2 here, divide by 2 there, and that means a is equal to 1. So in the place of a, we have 1n squared. Okay, but that 1 is a silent 1. It's like God, forever present but unseeable. And just because we don't see him with the naked eye does not mean he does not exist. He is there, ever present. Okay. Then the last question says, if there are 15 rows, find the total number of seats in the theater. I repeat, if there are 15 rows, find the total number of seats in the theater. I'm gonna leave that up to you guys to actually figure out, and then I'll just wait for people to give me their responses and their final answers for what they think should basically be how we go about it. Please type everything and anything that you are thinking should be done with this question. How do we go about answering this? If there are 15 rows, okay, find the total number of seats in the theater. This is grade 12, my pinky is 8. Okay, no problem, Ritabile. Yeah, you're sorry, I'm saying no problem. No problem, Dwani, if that's what you meant. It's like, I am guessing it's 360. Ritabile says Tn is equal to n squared plus 9n. Okay, so I'm guessing that's the answer that was previously given for the previous question. Snetlandla is the only one that has guessed as to what the answer is for the question that I have there. If there are 15 rows, find the total number of seats in the theater. Ivila says, I think it's 360 as well. How did you guys get 360? If I am asked, the both of you, how did you get 360? Maybe enlighten us there. What did you do and why? What did you do and why? Anyone who has the Sibindi to share with us what they did and why they did what they did. It's one thing to Ritabile says T15. Okay, why is it T15? Why specifically do we substitute that 15 in the place of n to get our answer? And do we all agree, guys? Okay, Snetland, I think I'm guessing you were saying 15 squared, not 2 times 15, because 15 squared and 2 times 15 is not the same thing. Ritabile says they wanted the value, not the position. Yeah. Okay. Okay, nice. I get you guys. 100%. Nice, beautiful. Yeah. Because remember, guys, if they say this amphitheater does not actually end with 4 rows, but it ends with, there's a 15th row somewhere. All right. Then that last seat that's here will indicate how many seats we have in the house. That last seat in the 15th row will indicate how many seats we have in the house. So what we want to do is we want to take then the sequence of last seats, which we already formed, 10, 22, 36, 52. We want to take that nth term, substitute there, so that we can find, when substituting the position, which is 15, so that we can find what is the value of the term. That seat that is there on your last, as your last seat in the 15th row, what number seat is it? So it is 300, it is basically the 360th seat. All right, which would therefore mean that in total the number of seats you have in that theater is 360. Does that make sense? So if there are 15 rows, find the total number of seats in the theater. Yeah, so by finding that last seat, what is the the number of that last seat, the number of that last seat, we are able to actually then conclude about how many seats there are in the theater. Okay, so you guys are 100% correct. I agree with you wholeheartedly. So T15 is equal to 360, which means that is the 360th seat. Therefore, we can conclude that there are 360 seats in the theater, in the amphitheater. Word problem, eh? Yeah. All right. I think, guys, we are good. Let's proceed. Here's another question. What are your thoughts, guys? Calculate the Okay, Sekhamit, are you asking another question now? How many seats are the last row? Is that what you're asking? You're asking how many seats are the last row? Or you're asking another question? It's a very good question. So, what do you think? How many seats would be the last row? How many seats would be there? Okay. So that's just food for thought for the learners that are there. But yeah, this is the next question, guys. I wanted us to look at. If you guys have an answer to my dear friend Sekhamet's answer, it'd be beautiful to throw your comments there in the comment section so that our dear friend Sekhamet can actually confirm as to whether answer is legit or not. But the next question says, calculate the value of the following without using a calculator. Without using a calculator. Okay. So there, guys, we have 20, the sigma there. P is equal to 5, brackets P plus 1, the whole thing squared, minus sigma, got a 20 there, P is equal to 5, and then P squared. And they're saying here, calculate the value of the following without using a calculator. No calculator should be used. Okay? No calculator at all. So it's this minus that. And I think what's nice then also then is to establish what's the sum, what's the number of terms we are dealing with here for this sigma and that sigma. Okay. We know most what we do. This P is equal to 5 indicates the number we substitute as our first term to emerge, and this 20 signifies the number we substitute as our last term, all right, to get our last term. Same thing here, all right. Here we have P plus 1, the whole thing squared, all right, and this is neither, it's not arithmetic, it's not geometric. All right, so P plus 1, the whole thing squared, and we have P squared. So this is like an unconventional expression of the nth term. It's quadratic. In actual fact, both are quadratic. And we do not have a formula for the sum of quadratic terms. So here we need to actually apply a bit of logic. And I think if you were to actually do, an observation that is proper, and then apply the basics that you should be able to actually easily get to answer this question without doing too much. All right, so let's first deal with this sigma. As I said, P is equal to 5, 20, P plus 1, the whole thing squared. So this indicates where we start. So if we were to actually write down our series, 5 plus 1 squared plus 6 plus 1 squared plus 7 plus 1 squared plus, now guys, dot dot dot, we know that at the end here we are going to have 20 plus 1, the whole thing squared. All right, so that's just something to note there, that for this particular series, all right, at least the first 3 terms we can see, all right, we know almost that it will continue up until the 20 plus 1 squared. So let's just reveal what we have. We have 5 squared plus, sorry, not 5 squared, 6 squared, my bad. 5 plus 1 is 6. We have 6 squared, 7 squared, 8 squared, plus, now obviously we're going to have 9 squared, 10 squared, 11 squared, 12 squared, and so it goes up until 21 squared for this series. So I hope you guys see what we emerges from this series. Let's move on to this one. All right, let's move on to this one. Let's move on to this one. Okay, Cassidy, just a moment before your question. Let's check out this one, right? This one we know is actually going to be, as we see as well with this particular one, we are going to have 5 squared, because here we are substituting 5 squared followed by 6 squared followed by 7 squared followed by 8 squared. But you get the point, guys. What is our last? When we substitute our last, that's going to be 20 squared. Okay, so this here is supposed to subtract that there. So let me just for a moment then write this: 6 squared plus 7 squared plus 8 squared plus 21 squared, right? Minus 5 squared plus 6 squared plus 7 squared plus 8 squared plus, of course, up until 20 squared. I'm sure you guys can see what needs to be seen. Remember, this minus sign will be distributed to all these terms. Everything here is going to be negative, right? Are we together? Everything here is going to be negative. Okay, here this side, all that is here is positive. All right, everything here is positive, but everything within this particular bracket is going to be negative, because the negative sign is going to affect everything. Remember, this is minus the sum of all that is there. So if you look at 6 squared, it's going to subtract that 6 squared. 7 squared is going to subtract that 7 squared, because it's going to be negative. All right. Okay, I'm just wanting to kind of reveal this to you. I'm not using a calculator here. Okay, I'm just simply applying some logic. Minus 5 squared minus 6 squared minus 7 squared minus 8 squared minus all the way dot 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 to minus 20 squared. This 6 squared is going to minus that 6 squared. That 7 squared is going to minus that 1. Everything in between here is going to minus everything else in between here up until negative 20 squared. So what is left behind ultimately here, guys? What do we have left behind? The 6 squared is going to bounce. But here, the only thing in this bracket that will be left behind will be 21 squared. Do we agree that that's the only thing? This is going to bounce. That's going to bounce. That's going to bounce. Everything else here is going to bounce except 21 squared. On this side, the only thing that gets left behind is minus 5 squared. So this is basically what I mean by the fact that here we need to apply just a little bit of logic, because the difference between p plus 1 squared and p squared is just 1. So that is why, for instance, with your terms in your series for this sum, you had 5 plus 1. The only difference is 6 squared, 7 squared, 8 squared up until 21 squared. Yes, Kulekan. There's logical common sense that we apply here. All right, because as we said, this here is not a arithmetic series nth term. It's more of quadratic, as well as this as well. It's not arithmetic, it's neither geometric or arithmetic. So our formulas, we are hands off from the formulas in this question. But it's easy to fall into the trap of thinking, well, if you don't observe the expression properly, you may easily fall into a trap. Okay, and find yourself using formulas unnecessarily and then missing the plot. Okay. Yo, hi guys, that one, it was not my doing. Someone else became a little bit excited, so yeah, but it's times like this that I appreciate, and I'm hoping you guys are appreciating. Oh my goodness, that is so funny. The way that happened was so good, like, yeah. And Sekhamedze just finds a reason to actually send me a "you awesome." I believe you feel that magic trick was awesome, right? Okay, no, that's good. Yeah, guys, you see, in this life we can make things appear and disappear. Oh man, that was AI, by the way. That was AI at its best. Okay, AI at its best. Okay, so I hope we understand then the emergence of the two series that we have. This series, like I said, oh my goodness, and I think Sekhamedze is just eating this one up, because now I think I understand this whole this profile picture of yours, Sekhamedze. I think you did indicate that you're a female, but like now I see your profile picture and I'm like thinking to myself, isn't that like a magician sort of attire in your profile picture? Okay, anyways guys, so from this emerges this series, okay, and then from that, this here emerges the second series. Okay, how many marks is that? You guys love marks, don't you? Love marks. It's like every single time now I have to be ready to give that answer of how many marks. How many marks does it say? Okay, let me just check. It's 4 marks, eh? It's 4 marks. Give 4 marks. All right. Yeah, it's 4 marks because it's an unconventional question, you know, that basically, like I said, the nth term here, or the p term, if you want to call it that, the general term that we have is not geometric or arithmetic, but rather it exhibits another quality, which in this case is quadratic. We don't have a formula that we usually utilize when we're wanting to find the sum of n terms for a quadratic series. So here, as I said, designed in such a way that you can actually write out the terms and then you can actually subtract the prevailing terms that repeat themselves, all right, because of the subtraction sign. Remember, the subtraction sign is distributed to all terms there, then we can subtract and we can write what remains. So that's 121, guys, minus 25, which you guys should be able to give the answer to very easily without necessarily being someone that, you know, would use the calculator from the onset. So you could say here we showed our steps, right? We showed our steps. The series first and foremost from the first sigma, then the series that prevails, that prevails in the second sigma. Then after that, guys, all we do is we actually subtract, we write what's left over, and then we subtract 121 minus 25, which gives us what, guys? What's 121? No, sorry. 21 squared is not 121. Sorry, guys. Me, I'm thinking it's 11 squared here. What nonsense. 441. My bad. Askisne. Thank you so much for that clarification. Me, I think I'm lost in this magic trick that just happened. I'm sorry about that. Okay, 441 minus 25, guys. Then that should give us a nice answer of 416. Thank you, Ivile. Thank you for that. I guess the AI. Hey, Ritabile, wena. Ritabile, you are hilarious. You are unbelievable. How could you use that against me? How could you? The nerve to use that against me. Can we hear those chunks? Are you serious? Okay, guys, this is basically, yeah, this is what I call goodness, eh? Yeah. This was no magic trick. This was legit. This, guys, is super duper legit. Very good, sir. No AI. No, it wasn't AI, it was legit. Okay, let me give that to you guys. Let me give this one to you now. I think let me give you a problem that you can work on your own here. Well done, sir. So Ramete, you are unbelievable. Ish. Yeah, now people's mouths are watering. Okay, here's a question for you guys that you can do. Let me give you this one to you guys to do. In a geometric series, T6 is equal to 6 over 32. Yesterday we did questions similar to this one, and T2 is equal to 3. They are what, guys? In a geometric series. Now they explicitly are giving us T6 is equal to 6 over 32 and T2 is equal to 3. The series consists of positive terms. Find the first term and the constant ratio. Okay. Right, this is your guys' time to shine. Come on, shine for me. Yo, Cassidy, you are funny. Yo. Yo, you are not for real. Cassidy, where in the world did they get you from? Hey, look, guys, whilst you shine in the maths, me, I shine. Oh my goodness. Guys, that's all. So in a geometric series, T6 is equal to 6 over 32. T2 is equal to 3. The series consists of positive terms. All they want is find the first term and the constant ratio. That's it. That's all they want. The first term and the constant ratio. That's all they want. That's all they want. Well, hopefully you see it now. Okay. We good, we did. Okay. Nopinki has gotten something there. Can we confirm Nopinki's answer? Nopinki says A is 6 and R is equal to half. Can we confirm that or disagree? Agree, disagree, or we agree to disagree, or we disagree to agree? Okay, so if you remember, guys, this particular question, we did similar questions yesterday, where we set up two equations, you know. T6, hopefully we understand if it's a geometric series. Oh, definitely awesome, Cruz got the same answer. Nopinki, I love your name, Nopinki. Is Nopinki your actual name? Nopinki Oganye, is it like a nickname? Got the same. Okay, awesome. Okay. T6 is equal to 6 over 32 and T2 is equal to 3. So hopefully, guys, you wrote down term 6 as AR to the power 5. Okay. Yeah, because it's always, if it's term 6, then obviously the exponent is always 1 less than the value of the position. Okay, it's always 1 less. Then T2, so we have equation 1 have equation 2. Then what do? Divide. We know most we divide. So we are going to say equation 1 divided by equation 2. Okay, a and the a cancel. We are left with r to the power 5 minus 1, guys. The other side we have 6 over 32 divided by 3, which is the same thing as 6 over 32 times 1 over 3. So r to the power 4. Let's see. 3 goes into 6 how many times? In the numerator, 2. So that's 2 over 32. Is that correct? 6 over 32 divided by 3, which means 6 over 32 times 1 over 3. 3 goes into 6 2 times. We have 2 over 32. We take the fourth root there, right on either side. Interesting. Maths in December. Yes, definitely. So it's supposed to say 2 divided by 1. Makes no difference. Makes no difference. Makes no difference. I'm unmuted mostly. Yeah, I'm unmuted. Okay. Yeah, sorry guys, I just had to make sure that I finished the magic trick. So it's complete. Okay, you remember there was things that were full, now they are gone. I just had to complete that magic trick, guys. Okay, now I'm here, available, fully so. Okay, r to the power 4 is equal to 2 over 32. So yes, guys, 6 divided by 6 over 32 times 1 over 3. 3 goes into 6 how many times? Twice, which is what we want. 3 goes into 3 once, 3 goes into 6 twice. So we have 2 over 32 as the answer. Then what do? I mean, I can take the fourth root on both sides so that I can cancel that root. That gives me r, but remember what I do on the left, I do on the sweet, amazing right. Okay, yeah, we say the fourth root of 2 over 32. So let's go to our calculator and actually go and type the fourth root of 2 over 32. We just, where's the, okay, that button, we say shift, we choose that button so that we have 4 there. Then we come inside, we write 2 over 32. Yes, r is equal to a half. Ritabile, you are 100% correct there. It's a half, my dear. R is equal to a half. Okay, simple, straightforward, just like that. Yeah, because mostly you can simplify 2 over 32, it becomes 1 over 16 if you wanted to actually do it in another way, because you know most you can simplify 2 over 32, it's 1 over 16, and then this becomes r to the power 4 is equal to 2 to the power negative 4. Just depends on who wants to do the problem. Then you can raise both sides by the exponent 1 over 4. That gives you r is equal to 2 to the power negative 1, which means r is equal to half. So that's just another way of looking at the same problem. Okay, I just so that you guys know. Yeah, so calculator approach, more exponential, simplifying exponential, changing 1 over 16 to be 2 to the power negative 4, taking the rational reciprocal of 4, which is 1 over 4, and doing that on the right hand side too, and then getting 2 to the power negative 1. You know that a base raised to a negative exponent, that's 1 over 2. Then remember, we want a as well, because what did they ask for? They said they want us to find the first term and the constant ratio. So we have the constant ratio. What we are missing now is the first term. So we can go, let's just go there to equation 2, and then say a into 1 over 2 is equal to 3. Okay, then what do we do, guys? If we want to find the value of a, we just multiply both sides by 2. Because this is 1 over 2, we can multiply by 2 over 1 both sides, or we can divide both sides by half. At the end of the day, if we multiply both sides by 2, a is equal to 6. Okay, so that's the constant ratio, and that is the first term. And I think that works out quite nicely and smartly. At the end of the day, we are able to get our answers. All right. Yeah. Thank you, Sekhametsi. Sekhametsi is very kind. It's like Sekhametsi waits for this, you know, for magic tricks to happen or for answers to emerge, and then voila. Thank you, Sekhametsi. Really appreciate the kindness. It's really appreciated. Thank you. I don't underestimate, nor do I not appreciate the gifts when they come, because I know how scarce they are. So I really appreciate it a lot. Okay, guys, look at this question. This one is very interesting. You got me. Rifitla, what time today? Oh, when are we finishing? Let's take it up until 11:30. Is that fine, Tabile? Rifita, what that time. I love it. So is that fine? 11:30. Okay. Then that give you enough time to actually go grab your own magic trick. Hopefully that Kisipedi. That's fine. I'm really loving the speediness. It's always cool. 12 will be cool. Mzala is like at 12 o'clock. All right, we can push it up until 12. Let's just check. Ritabila, you fine with 12? I think Ritabila has some plans tonight, if you know what I mean. Interfering with the plans. Okay, awesome. 12. Okay, we'll cut it off at 12, guys. Okay, look at this one. The first term of an arithmetic sequence is what? Is 6. Please take note, guys. The first term is 6 of a what? Of an arithmetic sequence. The first, third, and 12th term of that arithmetic sequence forms the first 3 terms of an geometric sequence. Then the question is saying find the first 3 terms of both sequences. All right. This I'd like to give to you to do as well. All right. I don't have anything that I want to attend to whilst doing that. I just want to see what can you guys do with the given problem. I repeat, the first term of an arithmetic sequence is 6. So that first term is 6, right? The first, third, and 12th term, we are told, of the arithmetic sequence actually form the first 3 terms of a geometric sequence. So the question is then find the first 3 terms of both sequences. Let's go. And yes, 7 good marks. The first term of an arithmetic sequence is 6. Then they move on to say the first, third, and 12th term of the arithmetic sequence actually form the first 3 terms of a geometric sequence. The question is find the first 3 terms of both sequences. How do you move in such a scenario or situation? Mzala, I don't have my pen with me. I'll wait for correction. I wonder where are you that you don't have your pen with you? Do we need to send a search party to go and look for you? Okay, so I'm going to give you guys a chance to attempt the problem because I want you guys to also apply your minds, and to see what you can actually do with the given problem. Yeah.